Okay, our lesson today is 11.1. We're going to be talking about solving systems by graphing. So you may want to label these notes systems by graphing. A few things that we need to make a note of. Everything you're going to do today should be a review. You've learned all of this before in 8th grade, so I'm going to go pretty quickly through these examples. So just remember that a system of linear equations is when you have two, it could say or more, but today we're just going to have two linear equations that have the same variables. Generally, they're going to be written with like a bracket, and it'll say y equals blah, 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 and then maybe y equals something else. We'll look at those, but you need to first have that definition written down. And then the second thing is a solution. So solution to a system is any ordered pair. This says that satisfies the equation. So I'm going to say any ordered pair that makes both equations true. That makes both equations true. It will also be the point of intersection. So for example, in graph A down here, my solution is this point right here where they're intersecting. And you would name that as an ordered pair with however far that is. So for example, this one might be 3, 1 could be the solution right there. There are a few other types of solutions or systems that you might see. So you always have to have two lines. So you could have lines that look like this. Remember, these types of lines have the same slope. And when they have the same slope, because we're looking for the point of intersection, and there is, if you look here, there is no point of intersection, then that means that here we have no solution, because there's nowhere that they're going to meet. The last option is if we have lines that are right on top of each other. And so I'll draw those, I'll do one in black and one in gray here. These lines are right on top of each other, and you could make points all along these lines, right? There's an infinite number of points on this line. So if we think about how many times that crosses, well, it's an infinite number. So here we say you have infinitely many solutions. It's kind of like the same as saying all real numbers, except we just state it a little bit differently for systems. All right, so let's look at some examples. Okay, so notice here we've got equations in two different formats. One of my formats is y equals 2x minus 2. That's y equals mx plus b. So I'm just going to write this down so that you have something to remember. Right, this right here is my slope. There's my y-intercept. This is why you got to be really good at graphing lines. So I'm going to start at -2. Notice that my graph is counting by ones now. That's what I want. So I'm going to make my slope a fraction, 2 over 1. So up 2 over 1, up 2 over 1. It is very important that you make this pattern go all the way through your graph, or else you're not going to see where it intersects sometimes. My other equation, I could solve that for y, but for me, this is in standard form, and it's something that divides easily, so I can make my two equations, 3y equals 18 and 6x equals 18. When I solve those, I'm going to get my intercepts. All right, so I got x equals 3 and y equals 6. So now I can just plot those two separate points. X is 3. Y is 6, and now you need to use a ruler or something straight. If these graphs aren't straight or perfect, you're not going to see a point of intersection. Oop, like what I'm about to do. Let's try that again. All right, there we go. And remember, we're looking for the point of intersection here, which is where these two cross. So on this one, I'm going to say my solution is going to be at 2, 2. All right, let's look at another problem. Okay, you can just call these example 2 and example 3, another kind of numbered funky. All right, so let's look at 2 first. You should be able to go ahead and graph these. So I want you to pause the video. I know you may not have graph paper, but do your best and pause the video and try to graph these two lines up here. Okay, before you go on, you need to have graphed them, so make sure you've done that, or else what we're going to do isn't going to be helpful for you. Okay, there's my red line. You should notice that one. On my blue line, I'm going to do intercepts, so I'm going to pause and take a second to work that one out. Okay, so I got x equals -2, y is going to equal 4, and when you connect, you're going to kind of see a problem. Remember, we're looking for the point of intersection, and if you notice, these aren't crossing anywhere. So if there's no point of intersection, here we're going to say this system has no solution. What that means is there's no value for x and y that I can plug in at the same time and make both equations true. All right, let's look at B down here at the bottom. So again, I want you to take a second to graph both of those and see what you're going to come up with. So make sure you pause the video and graph both of those. All right, there's my first one. I'm going to use intercepts to solve my second one because it's in standard form. And you should notice now my lines are perfectly on top of each other. That means they're sharing all of the points on both lines. So because of that, this is another special case where we're going to have infinitely many solutions. So that's how we state that, infinitely many solutions. And you'll notice I abbreviate a lot of times. All right, the last part here is word problems. This is why we've been practicing word problems this week. All right, so notice now you're going to have two different scenarios. So not all the information goes with the same equation. So my first one is going to be about Rock and Roll Bowl. So I'm going to underline all of that. All right, they charge $2.75 per game and $3 for a shoe rental. Notice that $2.75 per game is a rate, and $3 for a shoe rental is a starting value because you have to at least rent shoes before you can start buying games. So because of that, I'll use R for Rock and Roll Bowl. So R equals 2.75x plus 3, where x here is going to stand for the number of games, because it says per game. Game is your variable. All right, I'm going to switch to blue. So now if we talk about the other one, take a second, make sure you can write the equation for the Super Bowling. And to do that, I'm going to have the Super Bowling equals 2.25x plus 350. Now if you just look here at the equations, just take a second to think about them. It's more expensive to rent shoes at Super Bowl, but it's also less expensive for the game, right? So we're trying to figure out, when do they break even? When does it make sense to go to Rock and Bowl, and when does it make sense to go to Super Bowling? So they're asking, when will it be the same? So anytime you see the word the same, you may want to put a little star in your notes. The same means you need to solve a system, which is what we've just done, is written a system. So I'm going to scroll down here so we can look at our graph. And they're wanting me to graph these two things. So if I start, I'm going to do the red one first. I'm going to start at $3. I need to go up $2.75 for one game, which is going to get me to $5.75. You may need a calculator to do that. And you're just going to keep getting values so that you can get a straight line there. So I'm going to pause and do that. Right, I wrote my values above those corresponding points just so that you could see what I was getting. Use your calculator to get those if you need to. And now I'm going to do the same thing for my blue equation. All right, so there's my blue line. And if you can't see the question anymore, but it says how many games and at what cost will they be the same? So we're looking for this point of intersection right here at 1. And if you notice my values, that means we want to write a sentence. So after one game, both locations will charge, and if you see, both of them are $5.75, so $5.75. Remember, when you write money, the dollar sign goes at the beginning of the number, not at the end. I know you read $5.75 or $5.75, but the dollar sign has to go at the front. That's a pet peeve of mine. All right, so there's going to be my answer. And then we can even think about which if you're going to play like 3 games, which place is better? Well, it looks here like Super Bowl would be better for 3 because it's going to be below the other one. So we'll talk about that part a little bit more tomorrow. So let's see about your challenge questions, or I'm sorry, your lesson check questions. All right, these are the 2 things you need to be able to answer when you come in. We may have a little quiz on these as soon as you come in tomorrow on Classroom, so make sure that you can answer both of those things.